In this video, we're going to begin to study trigonometry in pre-calc. We first do a quick review of the 6 trigonometry ratios from geometry, which was a number of years ago, right? So let's look at this example here. I've got a right triangle ACB with C being the 90 degrees. So let's see what I can get. By definition, in geometry, sine of an angle theta is the opposite leg over the hypotenuse. So if I look at angle A, sine A would be BC over AB. And cosine is adjacent AC over hypotenuse AB. And tangent is simply opposite over adjacent, which is BC over AC. Right? And next it says the secant of an angle theta, abbreviated as secant theta, is defined to be the reciprocal of cosine theta. So if I cosine theta. So if I have cosine A being here at AC over AB, so secant it's simply AB over AC. In other words, it's 1 over, I'm sorry, it's the other one, not this one. Sorry about that. It is 1 over cosine of A. Oh, that's right, that's AB over AC. And cosecant would be 1 over sine A, so that would be AB over BC. And cotan and tangent are reciprocals, so I simply switch the numerator and the denominator. Same thing as well when we look at angle B, opposite over adjacent. In this case, the opposite is AC. Opposite over hypotenuse. Hypotenuse is AB. And cosine B would be adjacent, which is BC over hypotenuse AB. And tangent would be AC over BC. And cotan would be reciprocal of tangent. Secant would be reciprocal of cosine. And cosecant is the reciprocal of sine. Right? These are the definitions of the 6 trigonometry ratios. Also recall, there's some notes on the right-hand side here. Also recall that A and B are complementary angles because this is a right triangle with C being 90 degrees. So the sum of angle A and angle A and an angle B is 90 degrees. And then let's look at sine of A and cosine of B. It's exactly the same. And also cosine of A and sine of B are the same. So when you have complementary angles, when you have 2 angles that adds up to 90 degrees, their cosine and sine should be reversed when you look at when you take their trigonometry ratios of sine and cosine. So it's a quick way to verify that your calculation is correct. Now let's look at the bottom half of this page. It says, use trigonometry ratios to find missing side length and complete the models, complete the tables. Here we're told that angle C is the 90 degree, angle B is 45, CB is 5, and we're asked to find the length of AC. So because AC is the opposite leg and we know the adjacent leg BC, so probably the best thing to do is to use tangent. Let's see if we can do that. Should be AC, opposite over adjacent, BC. So tangent 45 degrees should equal AC over BC is 5. Tangent 45, if you use your calculator, is 1. 1 times 5 gives me AC equals 5. Then it actually gives you the answers here, verifies the answers here. If AC equals 5, so now we have an equilateral triangle, find the length of AB. Of course, you can use Pythagorean theorem, but probably a better way to deal with it is to use trigonometry, because then we don't need to deal with square roots and all of that. So we can still use the same angle, 45 degrees, and use opposite leg over hypotenuse. So sine 45 degrees equals 5 over AB. That should be your answer there. Okay, because sine 45 equals 2 and 2 square root 2. And if you do your algebra right, that's the answer. Now, it's asking you, what do you, if you multiply CB, which is 5, by root 2, you will end up having 5 root 2. What do you notice? And so you may want to just write a quick reflection down here. We went through this in special triangles. If you remember the ratio of special triangles, that will be really helpful. Next problem, in this triangle here on the right, also ACB. Here's another special triangle with the angle B being 30 degrees. So let's see what we can do. It says AC is 5. That's good. We know one side, we know an angle. We're asked to find CB, and we can use the same method and use tangent and solve for CB. And then it goes on to ask you to solve for AB, and you can use the same method as well. So I will leave you to do this, but I will give you the final answers here. AB is 10, and this becomes 5 root 3. And if you multiply AC by 2, that becomes, so 2 times AC equals 10. 2 times 5 equals 10, which makes AC equals AB. 2AC equals AB. Interesting enough. See what conclusion you can draw from that. Okay, so again, a quick review of geometry using definitions of sine, cosine, and tangent, but we also learned secant, cosecant, and cotan, as well as a quick review of special triangles and the relationships of the side length between the two legs of the right angle and the hypotenuse. Now, let's look at next page. I don't know what they're referring to, page 577, but basically it's what we just learned about the relationships between, this is what we learned about the relationships between the two legs and the hypotenuse, and with respect to the 30, 60, 90, and 45, 45, 90 degree special right triangles. So I won't go through that. Let's move on. Now, to solve triangles, we have to find all missing sides and missing angles. And the easiest way, if we are given some information, the easiest way is to use the trigonometry ratios. So let's look at how we can apply that. Here we have AC being 11, BC is 16. So if I want to know angle A, probably I can just take a tangent, since I have opposite at 16, adjacent at 11, right? So I have two sides, and then if I do an inverse, if you remember these little negative ones on top of 10, the inverse of 16 over 11, that should give me an A. So in other words, all I'm doing is I'm switching split places by adding a little notation so that I can find the tangent inverse. And if you do use your calculator, there is a function there, and that will give you A is approximately 55.5 degrees. So the calculation is fairly straightforward. Now, if you want to do the same thing with B, angle B here, so you can do the same thing with tangent B, which is opposite over adjacent. And then you do the inverse of 11 over 16. That should give you B. And use your calculator. It should be approximately, I should have used approximately, 34.5 degrees. And if you add A and B together, they should be, the sum should be 90 degrees. That tells you they're complementary angles, right? So do the next practice on your own. It shouldn't be too hard.